Okay, let's start with a problem that asks us to calculate the number of protons required to synthesize one ATP molecule by ATP synthase containing certain number of C subunits. So we'll start with part A, which focuses on ATP synthase containing 10 C subunits. So we know that in this case, 10 protons would be required to synthesize 3 ATP. And that will be achieved in one turn of ATP synthase. Or as it has another name, F1, F4 ATPase. Then the next question is, what is the P2O ratio for NADH in this case? So P2O ratio reflects the number of ATP molecules synthesized using the energy provided by transport of 2 electrons, in this case, originated from NADH, right? So we know that for 10 protons, we synthesize 3 ATP. Now, NADH, those 2 electrons that are donated from NADH, enable translocation of 10 protons into the intermembrane space. Out of the matrix. So it means that those 10 protons will be available. And how many ATP molecules are synthesized using the energy of those 10 protons, those ones? That would correspond to the P2O ratio. And we just saw that this P2O ratio in this case for NADH will be equal to those 10 protons multiplied by 3 ATP and divide by the 10 protons that are required to synthesize 3 ATP. And that will bring this P2O ratio to 3. Now, for part B, when we have 50 C subunits in this multi-enzyme complex, we will have the same logic, but instead of 10 protons here, we will have 15 protons that are required to go through C subunits in order to enable one turn of ATP synthase. And this one turn would yield 3 ATP to be synthesized. Now, for one ATP to be produced, correspondingly, we have 15 by 3, 5 protons required, right? And in the first case, it's 10 by 3, right? Protons to synthesize one. That's the answer for the first part of this question for part A. So here we have 5 protons required. Now, when we are determining P2O ratio for NADH in case of ATP synthase with 15 C subunits, we follow the same logic. So we have, again, 15 protons that are required to synthesize 3 ATP, or you can say that 5 protons are required to synthesize 1 ATP. So how many ATP can be synthesized using the number of protons translocated as the 2 electrons from NADH go through the electron carriers of the electron transfer chain. So in this case, we have, and it's always the case, right? Unless something is broken in the machinery. So we have 10 protons available. Due to translocation using the energy of 2 electrons from NADH, right? And that would correspond, and that would enable synthesis of 2 ATP, which would correspond to P2 ratio in this case. So the more C subunits, the less number of ATP molecules can be produced using the energy of those 2 electrons provided by NADH, or in the case of complex 2, FADH2 succinate.